Okay, what I would like to spend the last 9 minutes of this lecture on is graphing again. And we'll just deal with sine here maybe for a bit. So remember when we're graphing this function, sine x here is pi over 2, here is pi, here is, oopsie, 3 pi over 2, and I didn't make it long enough. Here's 2 pi. Here's the general basic graph, and I'm afraid that you're kind of going to have to know, well, definitely going to have to know this basic version of all of these functions. So we know that sine is never bigger than 1 and never less than -1. And I think sine would like to be in red today. We know that sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And let me there. And the sine of 2 pi is 0. The sine of negative pi over 2 is -1. Because sine is an odd function. Okay, so my dots aren't exactly right. -1 should be a little lower. Sorry. Sine of negative pi is 0. Sine of negative 3 pi over 2 is +1 because it's an odd function. And sine of 2 pi is 0. And now let's draw our... ouch. Okay. Okay, so I actually was in art school, but I was thrown out. Maybe you can see why. So this is the world's ugliest sine function. However, it's something that we can at least work with a little bit. Okay, so what would happen if you multiplied this function by 2? So if f of x equals 2 sine x, what happens to this? Well, for every value, sine 0 stays the same. I guess we'll do this one in green. So, and I suppose I better put some numbers up here because I'm going to need them. We'll call this 2. We'll call this -2. Sine 0 is still 0. 2 times 0 is still 0. Pi over 2, sine pi over 2 is 1, so this will be 2 times 1. I hope what you can see is that this is going to stretch this out like this. And this will be negative, this will be 0, this will be here, this will be here. Now let me see if I can really make this somewhat better. Ooh, ouch, ouch, oh. That's not bad. Okay, so I'll put this up. So this is 2 sine x. And you remember doing this in algebra, right? If you put a positive number greater than 1 in front of a function, basically it stretches it out, right? Similarly, if it was negative, it would turn it around the x-axis, which I'm not going to do because this drawing will become a mess. What I'd like you to think about where we're going to be going is, what would something like sine of 2x look like? And before we go on with this, some things that I want to make sure you're okay with. 2 sine x in general never equals sine 2x. They do at x equals 0 in places where it's 0. But one of the things that you have to know is that 2 cannot be pulled in and out in any kind of way. Also, another thing, be careful of, just occurred to me, sine x squared is not sine squared x. This is a dangerous way to write this. This should be like this. This means that the variable itself is squared. So just keep these in mind. How are we going to graph sine of 2x? Well, we'll plug and chug some numbers. When x is 0, sine of 2 times 0 is still 0, so here is 0. Maybe now, okay, if I wanted to go to pi over 2, so first I went to 0, and that mapped over to 0. If I go to pi over 2, then sine of 2 times pi over 2 is the sine of pi. Once again, this is 0. If I go to pi, this will be the sine of 2 pi. This is also 0. Pi goes to this. Similarly, if I go to 3 over 2 pi, multiply 3 over 2 by 2, the sine of 3 pi is going to be the same thing as sine of 2 pi plus pi. 2 pi is periodic, right? We can pull that out. This is the same as sine of pi. This is 0. The sine of 2 pi times 2 will be the sine of 4 pi. This is 0. Hopefully everybody can start seeing that all of these points are 0. So what's going on? What we need to do to find the look of this is cut this in half. Let's go to pi over 4. And so what's halfway between pi over 2 and pi? It's going to be 3 pi over 4. And for right now, I'm just going to put these in because I think we're running out of time. And we'll see how much more I can. So we'll go minus pi over 4 and minus 3 pi over 4. And why did I do that? Because now at pi over 4, let me get some erasing action going here. At pi over 4, the sine of 2 times pi over 4 is the sine of pi over 2. This is 1. So this becomes 1, which is right here. The sine of 3 pi over 4, so now it's going to be 2 times 3 pi over 4. This is going to end up being the sine of 3 pi over 2. Well, let's go back to our original graph. What was the original function at 3 pi over 2? It's negative 1. So this is going to be negative 1. Similarly, once we plug in negative pi over 4, we don't have to do this computation because we know that sine is an odd function. At positive pi over 4, it was 1. At negative pi over 4, it's got to be negative 1. And I can see this is starting to get a little messy. At minus 3 pi over 4, it's going to be the negative of 3 pi over 4. This is going up to 1. Okay. And now let's connect the dots. I got a bunch of dots to connect. So it goes here, 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 and you can probably extrapolate that it's going to be doing this, right? Because it's a periodic function, and this isn't going to be perfect. I'm just cutting these places in 2. Whoa. So what happened? When we multiplied inside by 2, basically, during the original, we had what? 1, 2 waves right here. When we've done this, what do we have? 1, 2, 3, 4. We've essentially doubled the wave count in here. And we're going to be talking a lot more about this. Not so much because I care that you can graph these. You have graphing calculators or computers when you're working. But to understand what's going on when we start changing something inside here, because in the next couple days we're going to be talking about phases and amplitudes and things like that. And this is a first kind of look at it. So, there it is. Do your homework, study, be happy, make A's. See you tomorrow.